Hi, everyone, and welcome to the session on Introduction to Deep Learning. And thanks a lot for making it at 7 p.m. in Vegas. I know it's not easy. But before we get started, though, so just to get the energy back up and get everyone in the space where we need to be for this talk, I want everyone to make as much noise as possible on my signal. 3, 2, 1. Thank you. Thanks. So again, I appreciate you making the time to come here and talk to us about deep learning today. It's this topic. I'm a business development manager at Amazon AI. And essentially, I've been at AWS for about 4 years now. I started as an engineering manager in the support team. I helped building the support team for big data, and then so we launched a number of products like Spark and then the Hadoop ecosystem. And I was also managing a specialist team of DevOps guys. So we're doing CI/CD and all the adoption of Chef and Puppet and all that. And then before that, I'd also worked, on professional services and engineering team management. And I sort of know the pain of moving from on-premises or doing things yourself to starting to adopt the cloud and starting to adopt and launch and grow and scale multiple technologies. And the reason why I give that background is because, that whole big data time and space and storytelling is really happening again now for machine learning and deep learning. Well, back in 2009-ish, everyone was interested in big data. Everyone wanted to do things with Hadoop, but not a lot of people knew exactly what it was. So I have a feeling we are the same space now where everyone is interested in machine learning, everyone is interested in AI, but there might be some things that we can do to first clarify what it is to everyone, and secondly, help you accelerate in your adoption of machine learning and deep learning. So that's why I'm here. So this is really designed to be a use case talk and in parties, an introduction session. So I hope you get some value out of it. But the first thing that I want to talk about is the cycle for AI, sort of a way to get us at the same, in the same space as far as AI is concerned. And AI is really about, getting machines to perform in certain spaces that are natural for humans to operate in, and to get a machine to get as efficient as humans in that space, like in a vision space. We can see almost naturally. We don't really know what happens in the background, but we know we can see. We can learn a language almost naturally. We don't know what happens in the process, but we just know that we can speak a certain language. What happens in between? So the goal for AI, in the way I like to put it, is to really put these human functionalities and features into a machine. And how do you get that done? So going through the cycle for AI, one of the key things that people do, as far as the process is concerned, is that they perceive, right? I can perceive with my eyes, I can perceive with my ears, I can perceive with some sensors when I touch things or when I feel things. So once I perceive something, one of two things happens, or two things happen. One is I either know the thing that I saw, or I can either feel the thing that I touched. So I have a certain knowledge representation of what I just perceived. The other thing that can happen is that I don't know the thing that I saw, but I'm learning from it. I see that, I didn't know it was a bottle, and someone tells me it's a bottle, now I learn from it. So you have two things that can happen in the process of human-world interaction, the way I like to put it. And once I figured out what I just perceived, the next thing that I do is that I reason on top of that, right? So I apply my own reasoning on top of it. And after a reason, I essentially plan a certain set of steps, and I execute on them, or I execute directly. Practically, in a conversation or a dialogue, when you speak to me, I perceive with my ears, and after I perceive, I have a knowledge representation of what you just said. I either know what you said, or I learn from something you say, and then I reason on top of that, and I plan whatever I have to say, and then I say it, right? Sometimes I say without planning, but that's another topic, right? So, and then the way we perceive is, by using vision and language, like I said, speech and sensors and different other things. And the way we have a certain representation of things in our mind is either by using our memory, that's where we store things that we know already, or by using our brains in an adaptive way, right? That's how we learn on the fly. And after that, we act using certain actuators. I can speak, I would use my voice as an actuator, or I can touch things, or I can move things around. That's the way I can act in the real world. So the way we implement that in the machine with AI is to essentially perceive with different input mechanisms or vehicles, like cameras or audio data or sensor data, clickstream, user activity. Any data generation tool can be used as a perception input tool, essentially. Right, so once you have the data in, you either know something about it, you might have a graph database somewhere with a knowledge representation of the information you just captured, or you learn from it, and that's where we come in with machine learning and deep learning. So machine learning and deep learning essentially help you apply the adaptive way of learning from the things that you perceive through the data and through a certain number of input mechanisms. And after you have that, you essentially have AI, right? So because after that, the machine can go through the cycle of AI and interact with the real world in the way a human would have, right? And that's how you have a certain form of artificial intelligence. So to put things in perspective, the way I define it is that AI is really this umbrella term for any form of machine interacting with the real world. There are multiple versions of AI. There's some, and the different schools of thoughts as well. There are different people that look at AI in different ways, but the way I like to talk about it is that AI really gets you some interaction with the real world, like self-driving cars, and that interaction with the real world might be visible and it might not be visible, and I'll talk about it. The visible one is the one that you see in most advertisement of artificial intelligence, like self-driving cars or drones that are flying around and identifying objects. That's, you can touch it. The not so visible ones are things like recommender systems that are working in the back end to recommend things that you are going to wear or touch or see or, I don't know, consume in many different ways. And there's also another part of the not so visible AI that I'm super excited about, because I used to be an ops guy in the past. I used to stare at logs for hours and hours of days, trying to find an error. So nowadays you can use AI to do log processing and log analysis, and that's very, very important when you want to put systems in production, right? So to get to interact with the real world in different ways, AI uses machine learning. So AI really uses machine learning as a tool to do statistical analysis and pattern recognition and a different number of maths and statistics based calculations on top of the data to identify the patterns on the data. And that's what AI uses to essentially get the machines to operate in the real world as a human would have. And deep learning is a subfield of machine learning that tries to mimic the operation of the brain. In our brain, we have about 10 billion neurons, right? And all of these neurons essentially go ping or they stay off depending on a certain information that we've perceived. When I look at this room right now, I perceive a certain information through my eyes, and based on that, my brain is activated in a certain state, right? And then so that state of activation is what deep learning is trying to mimic, using what we call artificial neural networks, and then passing information through them, and based on the state of activation, represent a certain information. Now that's interesting because you can use that and use the GPUs that are now very popular as a processing platform essentially, and scale that exercise through a large amount of not only unstructured data set, but essentially a massive, massive quantity of data set, right? So deep learning is bringing in a lot of opportunities, and that's why we're excited about that, because it can't just help you do deeper and better analytics. It can also help you touch a lot of data. And as we all know, in the AI world, in the machine learning and deep learning world, data is gold, right? If you don't have data, you have nothing. And one of the cool things that, I'm going to talk about that later, but one of the cool things that I like talking about in deep learning is neural-machine translation, NMT, where back in the days when when folks were building translation systems, they had to build a database of words or sentences in one language and another database of words and sentences in another language, and essentially do some form of mapping, right? It worked, but the challenge there is that you have to grow that space over and over and over again. And you start missing out on things like sarcasm, you start missing out on things like proper grammar or vocabulary. My first language is French, and then in French, the way we structure a sentence is very different from the way we structure a sentence in English, right? So you miss out on that when you use that approach to translation, because you're basically using a bag of words mechanism. And one of the things that NMT brings in picture is that you can use this deep neural network architecture and stream in a sentence or sequence of words in, say, English, and based on the activation, have a certain thought, right? So the activation would be essentially what the deep neural network thought when it saw that sentence in English, and just take a snapshot of that activation, copy that, and paste that in a deep neural network that can speak proper German, or speak proper I don't know, Italian or Spanish or Portuguese with proper grammar, and just let that express that thought that you captured in the other language. So with that, you essentially say what that other network thought when you are interested in the language, the sentence in English, and then just say the same thing in your own words in German. And you get better translation, you get better grammar and a certain number of things. So deep learning is very interesting and exciting, and I hope that I'll get you fired up about that as much as I am now. So some of the key drivers for deep learning, spoke about it a little earlier. The first thing is fast compute, right? So Moore's law is over. Now we have GPUs with Volta is an example from NVIDIA that we have available on AWS as in the P3 instances that have about 120, I believe, teraflops. That's a lot. You can do a lot with that much compute capability. The other thing is ubiquitous data. The internet gave us a lot of data in the last 20 years, right? So with all of the data that was captured with the internet, we can have a better representation of the world. And back in the 70s and 80s, the mathematical concepts behind machine learning and deep learning were already existing. The algorithms are very old, right? But some of the challenges were this, right? And the different schools of thoughts as well. The different people that believe that they can approach machine learning and deep learning from different angles. But the angle of deep learning, as in using neural networks, had a challenge because there wasn't enough data to get the deep neural network to be as accurate as it is now. And then with that, in the early 80s, so people thought that it didn't really work. But when the internet came up and added a lot of data, the models and the algorithms started working better and better, and then you can have better models that are trained. The third thing is advancement in learning algorithms, right? So some of the algorithms are old, but there are many other ones that were created lately, and in that, so this sort of trilogy is making deep learning possible nowadays. So you can really get innovation with deep learning. That's kind of the promise of deep learning and all machine learning at the moment. So with that, you can solve some of the hardest problems in the world, like learning a new language or learning something completely new. You can solve perception problems. There are use cases or examples of gaze tracking, for example, in cars, in driver assistance models, where you have your car, which has a little camera there that tracks your gaze, and as you drive, it really checks there's deep learning models that is running on your car, and it's checking whether you're watching the road or not, or whether you're on your phone or not, right? And then with that, it can take over the control of the car and prevent an accident. So there are things like that, and those are perception problems. There are things like, of course, autonomous driving systems and a decent number of things, and reasoning as well. The way we use deep learning, we have been in the business at Amazon, we have been in the business of machine learning and deep learning for a little more over than 22 years, right? This is what our web page looked like in 1997-ish. So a lot of things have changed since then. But one of the key call-outs here is that we already had a personal notification service, right? The intent of having people to get personal notifications was already there, right? So, well, granted, a lot of things were manual in the back end here, where there's actually someone going through a list of people and going through a list of other things and trying to find correlations there and recommend products from that perspective, but the intent was there. And we've evolved through time and applied many, many methods of machine learning. At Amazon, we are more engineering oriented, right? So there's a lot of research that happens, and there's a lot of core research in machine learning and deep learning that happens. But at AWS specifically, when we come out with a product, that's after we've figured it out for a while, and that's after we've scaled that for a long time, and we make sure that it can work for a large ecosystem of customers in multiple industries and multiple verticals. So we literally talk about things once they're ready to go out, but there's a lot happening in the back end. So that was circa 1997. And nowadays, things look like this at Amazon, right? Where we have in our fulfillment centers these, what I call minions. Essentially, these are self-driving robots that are driving themselves around and are picking up these bins that are about 750 pounds. Oh, the video is a little buggy there. But the key call out here is that our agents at the fulfillment centers, they don't walk around and get tired by walking around to go and pick up packages, right? The packages come to them. And then these machines drive themselves. When they run out of power, they go and recharge and they come back to work and things like that. And we get much more efficiency from that perspective. Another thing is that we use a random storage mechanism because it's very efficient. We just throw objects wherever we see space. And we're working on using computer vision to identify the objects and the items within the bin and use a robotic arm to go and pick that up and bring it out. We also use deep learning and AI for heavy duty, like picking up large objects and things like that. And as far as recommender systems are concerned, this is what my Amazon.com landing page looks like, right? When I go on Amazon.com. As you can see, I read a lot of TensorFlow books. And the key call out here is that many things on the Amazon.com page are driven by machine learning and deep learning. From the product that you see when you come online to the products that we recommend to you, or we also do a lot of things like users, comments analytics, and sentiment analysis. Pretty much everything in the whole gambit of machine learning and deep learning is happening on the Amazon.com page. And every single widget and item that you have there has most likely a machine learning or deep learning model working in the back end. Now, these are recommender systems, and I'm pretty sure many of you have heard about recommender systems as well, because it's usually based on algorithms like people who bought this also bought that, or some form of heuristics based on what we know about customers, what we know about people. But there's another aspect of deep learning and machine learning that I'm super excited about, which is essentially giving you the possibility to explore items that we don't really know that you would like or not, right? So it's an exploration mechanism. There's this algorithm called multi-arm bandit that is getting more popularity, a lot of popularity, where you can essentially train an expectation maximization model or a regret minimization problem, any way you want to put it, and have a way to recommend items to users based on the confidence score that you have in that item being of interest to that user, and explore and take over the risk of making a mistake and proposing an item to a user that they might not like, but learn from that perspective, right? So you balance these two aspects where on one aspect you exploit what you know about your users, and then on the other aspect you explore what you don't know about your users, and that helps you learn, and in the fullness of time, you get more data points and you use those data points to get better experience for your users. So again, this whole talk is about examples and use cases, so these are things that are possible. And other things about deep learning at Amazon is, of course, Alexa. Who here is familiar with Alexa? Everyone, of course, yeah. Okay. So with Alexa, the reason I like calling this out is, it's about the deployment mechanism, right? So sometimes you deploy a deep learning application, and it sounds easy on paper, but in real life, there's a lot of things that you need to put in place, right? What is the throughput? How many requests per second? And all these plumbing questions come back in the picture. And Alexa has a cool deployment mechanism where there's actually a very, very tiny, small model running on the device, and that's it, right? This is just a speaker. And its only job is to identify what we call the wake-up words, like Alexa, right, or Amazon, or any word that is going to get it to wake up and get that blue line, blue circle to start, waving around. And after that, it opens up an MP3 stream and starts gathering information or data that it sends to the cloud for everything else, right? So what that means is that in the back end, you can scale all the learning capabilities and all the throughput and everything you want to scale from that perspective, and let a very tiny small model that is basically a vehicle to the rest of your deep learning ecosystem. And your deployment your deployments are very easy. You just change the backend, and then everyone has access to the skills right away. So if you're thinking about putting devices on the field, think about the deployment model like that, because it can help you scale. And sometimes when you go to production, the first 6 months are cool, but when you start adding features and you have to push that, to the devices, it becomes hard. So on that, like I said, we have over 20 years of machine learning, deep learning, AI at Amazon, and these are some of the use cases that we have running nowadays. And the list is way longer than this, but we have supply chain optimization, of course, advertisement, video content analysis. We do a lot of image analysis as well. There's also core research, core machine learning. We have thousands of machine learning scientists at AWS and Amazon working on machine learning and deep learning use cases. So there's a lot of machine learning and deep learning and AI activities happening. And this team, the team that I work for, is called Amazon AI. Our goal, really, our charter, is to pull all of that knowledge and experience and information, and by all, I really mean all, even the people, from Amazon.com and the other businesses of Amazon, and bring that to AWS and put that in the hands of every developer, right? So we're very serious when we say that machine learning in the hands of every developer in a few ways. If you want to democratize AI, there's a few things that you need to do, right? You don't just provide products and services and cool tools, but the real goal is to get people to solve their problems with AI, right? And at this stage, arguably, a lot of people are still at a stage where they need definitions, they need hand-holding, they need practical views and visibilities of, what is the next practical step that I need to take to adopt deep learning. So we're providing tools and products and services, but we also, and I hope you've seen the press release a couple of days ago, we also have an ML lab, which is essentially people and scientists that are working with AWS on deep learning and machine learning use cases and helping our customers, solve their problems with machine learning. But the way we have organized ourselves in providing AI and machine learning and deep learning to customers as products and services is in layers. At the top of the layers, we have what we call AI services. And the AI services are designed for folks that they might have the expertise, or they might not, but they have a problem that is fairly common in the deep learning ecosystem that we have solved already for them. And we put those in a few lanes. So remember these perception mechanisms that I spoke about, like the vision and the speech and the chat, the conversational ecosystem. So in these different lanes, we're building different products, right? In the vision lane, these are to get the computers to essentially get the vision capability. And with that, we have one product called Amazon Recognition. With Amazon Recognition, you don't need to train a deep neural network for image recognition or analysis. You just pass an image through the service, and it will tell you what it saw in the image. If I pass an image of this room to Amazon Recognition, it's going to tell me there are people, they're sitting, I see monitors, I see chairs, I see coffee mugs, I see a different number of things, right? So with that, you can have intelligent systems. You can augment the search space of your product by getting features that you extracted from images. If you have a hotel, or if you are in the hospitality industry and then you're advertising different images of different rooms, for example, many people put in the description of the room, but what if there was a piano in that room and I wanted a room with a piano with some musical instrument? By putting in the information that you saw from the pictures of a room, you can augment your search space and now have more intelligent results out of my search, and maybe I'll pick your products for that, right? So Amazon Recognition is very, very, very useful. Amazon Polly is a text-to-speech solution, right? You pass in the text to Polly and it speaks back to you. That's what Alexa uses to speak back to you, right? That's what we use in Alexa. It supports a decent number of languages, and it's very cool because with Polly, you can just pass in a whole document like a press release or a news article, and then it's going to read it back to you, right? And it can also do interesting things like whispering, or it can increase the speech, or do a decent number of interesting things. So you can think about the kind of things you can do with Polly. Amazon Lex is the brain of Alexa. We decouple the brain from the Echo device, and we pulled them apart, and we created Amazon Lex to give our customers the ability to create intelligent chatbots, essentially, And with that, you can just fill in the form, and by filling that form, you will have a chatbot, right? So what we solve here as a problem is the automatic speech recognition aspect of conversation, where you don't have to solve the problem of speech recognition, we'll do that for you. And the natural language understanding as well, understanding your intent, understanding what you mean. The chatbot understands that right away because we've encoded that knowledge in the model. So we do that for you, and all you have to do is to fill in the conversation steps, essentially, and what question it's going to ask and what answer you're going to provide for it to fulfill a certain operation on your behalf. So that first layer is for people that want to just use services. They might have the expertise, they might not, but these are very easy to use, and they're deep learning powered. At the second layer, we have what we call AI platforms. With the platforms, you might want to use machine learning or deep learning, but you have your own data set. You have your own, say, images, or you have your own custom images, or you have your own data. Maybe it's user activity from your website, or just a number of things, and you want to analyze that. So you want to do that, but you don't want to build a whole infrastructure from scratch, right? So you don't want to build clusters and configure them and install whatever you want to install as a software on top of that. So with the platform, we take care of that for you. We take care of the plumbing. We bring you up to about 60 to 70% of getting your whole infrastructure set up and operational. And all you have to do is to write your code or anything you want to do on top of that. Amazon Machine Learning is a simple service that does three things: linear regression, logistic regression, and multi-class classification is a service right there. So with AML, we essentially gave you an end-to-end way into taking simple models or simple data set, walking that through a service that would do intelligent things like removing missing values and removing items that are not contributing to the performance of your model, and then training that model on these three algorithms I talked about, and then giving you the output and outcome with a report on the performances of the model that it just trained, right? So very simple and very useful. If you're a Spark user, if you're an ML user on top of Spark, you can spin up an EMR cluster. I can get that done before the end of this talk and have about 1,000 servers working just like that, with Hadoop installed and Spark installed and Spark ML and pretty much everything you need, and Zeppelin from a front-end standpoint, pretty much everything you need to get started writing your PySpark or Spark jobs in order to analyze data at scale. It's connected with our security services like KMS. I'm going to talk about that a little more later. And it's also connected to the infinite scale data store, which is Amazon S3, which is the database of the internet today. That everyone uses, right? So Spark ML and EMR is very powerful. To ingest data in real time into the AWS environment, you can use Amazon Kinesis. And to ingest data in the batch mode, you can use AWS Batch. And if you're a Docker user and you like using containers to organize your ecosystem, you can use Amazon ECS. Again, the idea of the platforms layer is to make sure that you don't get to do things from 0 to 100. You get to do things from 71 or 75 to 100. If you are a deep learning user, so many platforms today are designed for the traditional, what I call the traditional machine learning operations. There are algorithms like logistic regression or principal component analysis or support vector machines, or tree-based algorithms like decision trees and boosted machines that are becoming very popular now. All of these are very good, but the current implementations of many of them require either a single machine to operate, like scikit-learn, or they would try to use the traditional big data ecosystem in order to apply some machine learning workloads on top of it. There's a challenge with that. The challenge is that in big data, parallelism is key, right? So you can have multiple workers that are working independently, and they can fail independently and wake back up independently and work like that. But with machine learning, you have this consistent view of an error that you need to optimize, that you need to minimize. So you can't really have workers dying and coming back up and things like that, because it's going to hurt the performance of your model. So although these work well in some of the platforms at the top layer, at the engines layer, these are really deep learning platforms or softwares at this moment that are built purposely for the deep learning experience, right? And in the deep neural network ecosystem, you remember the network structure that you have to pass data through. You have to do that, and you need to have this consistent view over the error that you need to minimize. So all of these are complex pieces that you need to put together, and if you're a little bit familiar with deep learning, you have to do a lot of derivatives in order to find out what is the rate of change of your error depending on the behavior of different neurons within the neural network. Again, that sounds complex, but that's the goal for these engines, right? The goal of these engines is to make sure that you don't get to worry about that. You just point it to your data, you design your network, and it passes the data through, and it computes the error for you. So what we've done in this ecosystem is that we've created a deep learning machine image called the Deep Learning Army that you can use, and again, it's pre-configured with many of these deep learning frameworks. They pretty much do the same thing with different levels of expertise in different domains. At Amazon, we back Apache MXNet for multiple reasons. It's very powerful, it's very lightweight. When you train a neural network with MXNet, it's very small, so you can put it in a device, and there's a lot of energy that is put behind that to make sure that it works with every other AWS tool. But we have a very open strategy at AWS as well, and that's actually a slide about the deep learning machine image. So our strategy is to make sure that it's similar to what we've done with databases. We have MySQL databases, Oracle databases, MS SQL databases running on an AWS environment. We also support every deep learning and machine learning framework that are popular and that our customers want. And we fund teams and we make them even compete on which team has the best support for the state-of-the-art deep learning and machine learning frameworks. So with that, you get a machine that has up to 40,000 CUDA cores. This is impressive. And you also get access to popular deep learning frameworks like TensorFlow, MXNet. You get Python 3, and you get a lot of notebooks and examples. So notebooks are the IDEs for data science. That's where many people write the machine learning and deep learning code. And it's really good for reproducible research or reproducible results, because as you write in the notebook, you can also comment it and you can document it. And if anyone goes through your notebook, they can reproduce the result that you've had, provided that they have the data. So what we've done and what we're continuing to do is to fund teams of folks that are just writing these examples in different domains, like demand forecasting or some form of recommenders or sequence-to-sequence models for translation. So we want to make sure that any example that our customers like are available in these notebooks. So again, a call out, if you have a use case or if there's anything you want to see an example for, reach out. I would be happy to task a team to sort of put together a template for you. And you also have a way to scale a cluster of these machines to have a multiple machines training mechanism, essentially. A lot of customers are doing deep learning on top of AWS. There wasn't enough space to put everything on the slide, so I figured I'll just have this much. For example, we have customers like NASA using AWS to pass voice command to the robots. We have customers like Clarify doing deep learning on top of AWS ecosystem for a lot of video analysis. We have customers like Slack and SIGOP doing pattern recognition. I'll get to talk about them a little bit. So there's a lot. We have customers and examples in multiple ecosystems, multiple verticals, from startups to enterprises. It's just a lot. So to get a little more specific, in computer vision, of course, this is going to be all about examples now. So in computer vision, we have a number of customers. I'm just calling out a few. I already spoke about Clarify. PowerScout is interesting because they are switching marketing upside down. Essentially, they're selling or they are marketing solar panels, and they use deep learning and computer vision to identify the houses that might be good candidates for a solar panel by just taking aerial views and analyzing that, right? I don't know if that's what they do, but I think that, if 3 of your neighbors have a solar panel, maybe you're likely to have one, So just that would be a very naive way to just pass a drone on top of many houses and see, how far you are from other people that have a certain product and maybe propose that product to you. So there are different ways. Onfido is using computer vision on top of AWS for essentially biometrics, identifying people, using their faces. GumGum is using computer vision on AWS to analyze images and a lot of content over the internet for targeted advertisement. So it's a lot of examples. In autonomous driving, which is one of the most visible aspects of machine learning and deep learning, we have this customer in China called Too Simple. They're building self-driving cars, and on the left side there, they have an object detection model running locally on the car, and this is interesting because you might have the best model in the world, but if the response time for that car is not good enough and someone steps in front of the car, then you hit someone, right? So the price to pay is very large. So in this kind of deployment mechanism, you have to train a deep neural network at scale with GPUs and whatever you can get on the cloud, with the power of the cloud, but you have to make it small enough to be able to deploy it on a car with limited power and limited everything that it has, limited memory, and it has to work as efficient as it would, with as much power as possible because the risk there is high. And this system works as well in the daytime as it works in the nighttime. And the other thing that they've done is, what you didn't see there is semantic segmentation, where they can separate, whatever is road from whatever is not road. In this example, the green stuff on the floor is basically identifying what is the road. So they put the two things together, the object detection and the semantic segmentation, and what they can get is a three-dimensional representation of the car with a centimeter accuracy. So they have a real-time heat map of a car, identifying objects, and knowing exactly how far they are, and that's how they can achieve a self-driving capability. The other aspects of use of deep learning is in medical and image analysis. We have a customer that had managed to have an FDA-approved medical imaging use case running on top of AWS. For a system to be FDA-approved, it has to have human-level accuracy. This was for congenital heart disease detection. Right, so they wanted to make sure that by analyzing a decent number of images and classifying them as healthy and unhealthy in a certain ways, they could pass a new image and be able to either identify it as healthy or not healthy, or highlight some things that would help the practitioners, like the radiologists or pathologists or whatnot, to, instead of having to go through 120 images to identify a certain tumor or something, go through 2 or 3, because the model already did the heavy lifting. This system could achieve human-level accuracy in about 30 seconds, and that's how it got FDA approved. So we have a number of other customers using deep learning for recommendation engines in the hotel industry. Expedia is very well known. Pinterest has a number of recommender systems, image-based recommender systems. Yelp is using deep learning on AWS to parse and analyze the user feedback and user comment. With a platform that big and large, you don't want to analyze every single user feedback and comment, right? You want to use an NLP system to stream in all the data, all the text, and do things like topic modeling, where you can classify different user comments and say, okay, all of these comments are talking about this, all of these comments are talking about that. And on top of that, you do other things like sentiment analysis, and you can filter out the space of comments that you look at, move from millions and millions of comments to about, I don't know, a couple of hundreds, and you get a human to go and review that and then take some actions. We also have use cases. I just spoke about natural language processing, but again, the Washington Post is using deep learning for NLP, Zendesk, and many people that have help desk systems, people interact with your users via the help desk system, right? People are talking to your agents, so they speak to them. People are sending emails and interact with the help desk. What if you could analyze all that space of information? What if you could merge the voice data with the text data and make sure that you get all that analysis back in front of the agents, and then make sure that by the time an agent or customer calls, they have all these different pointers and scores and satisfaction and happiness or any other thing to make sure that they get them, the customers, the best possible service based on NLP. So that's what's happening right here. The other use case for pattern recognition and optimization. Deep learning is good, it has happened and it's happening. But the next step is to get to the point where you get your analysis done or your patterns recognized the fastest way possible. If you've trained the model, I was just talking to my colleague over there, and I was telling her that I'm training a deep neural network, and I have been training that for about 12 hours now. So it takes a while, right? And those are the kind of activities that really work with the infrastructure that you throw at it. That's why GPUs are very important. It really works with how you optimize your data platform. It really works with how you optimize your your data format, if it's the best data format for the analysis, how you optimize the data schema, all of these things come in the picture. But it's another thing, which is how you can find the most optimal parameters for your model in the lowest, in the smallest amount of time, right? SIGOPT is a customer of ours that is essentially bringing in, what we call Bayesian optimization techniques to get to the optimal version of your model in about half the time it would take today by using some heuristics like Bayesian optimization, which is essentially using conditional probabilities to jump a search space of parameters and get to the optimal outcome in the shortest possible time. What many products are doing now is what we call grid search, where they would iterate through every single possible parameters in the grid and then get to the right parameters over time, but it just takes a long time. 2Sense is a customer of ours that is using behavioral biometrics to identify a person, and that's for authentication in a certain number of things. If you, as you use your phone, you have certain patterns about that. You have certain activities that you do. There's a certain way you type on the keyboard of your phone, and all of these could be used as identity, right? I might have a limp as I walk and different ways that I walk, and then if my phone could capture the way I walk, then it could help identify me or not me if someone took my phone, right? So there are a few things that 2Sense is doing using biometrics in order to identify a person. So if you drop your phone and someone picks it, then it would know right away that it's not you, and it's going to lock your accounts and access to you. It's a number of things that require authentication. And they're trying to use the same kind of things to get into your car or get in your house, and by just having that thing understanding and knowing you. There's a lot of other examples. And so one of the key questions here is how, right? So we've talked about examples, we've talked about what we do, we've talked about some of what our customers do, and one of the key questions that I get most of the time is, how do I get started, right? So the rest of this presentation is about giving you some, tips about, getting started. Well, the first thing, again, you want to start with data. Data is the most important thing. If you don't have data, you have nothing. This slide represents our application lifecycle and data lifecycle at AWS. Well, you want to ingest data, so you want to either upload that data set or connect using Direct Connect, which gives you a 10 gig pipe to throw data, or you want to use Kinesis for real-time data ingestion, or Snowball, Snowmobile. We'll talk about that a little later. And then once you have the data in our environment, you want to use the right data store for the right job. So we have data stores from object stores in S3 and Glacier to relational databases, non-relational databases, search databases. Pick your tool for the right job. And you also have compute capabilities in EC2 and Lambda and EMR and Redshift Spectrum. I spoke about most of these. And the idea here, the key call out here is that, well, strategically, we are decoupling storage from compute. So we want to make sure that you can store a single source of truth of your data set in a certain location and be able to compute that downstream with different tools that you choose and pick. That way, you can have a single owner of a certain data set in the enterprise or the company, and that person will give access to different other people that want to use that data set for analysis, and that's how you can achieve data and compute decoupling. And you can also save money from that perspective. Amazon AI is a list of products and services that I spoke about a little earlier that sit on top of these. And another call out is that all of these teams are working together. So they're fully integrated, and when you have a support issue, you guys can just work all together. So as far as ingesting data is concerned, if an upload mechanism doesn't work for you, you can use our Snowball Edge, which is a device that comes with a couple of Kindles, and it has a label for shipping over to you and label for returning that switches automatically. It has another Kindle for you to manipulate it, and it has onboard compute, so you can do some transformation right away on premises before you send the data up to the cloud. You can also cluster them locally if you have PII or PHI data that you can't push to the cloud right away, so you can get a number of these snowballs and bring them down and do your analysis from that perspective. Customers love our snowballs, so if you are a Snowball user, make sure you take a selfie and send that over, and I'll be happy to, put that in my next slide. This customer right here is a very happy guy. But you should never underestimate the bandwidth of a FedEx truck. That's what Snowball is sort of giving you in sort of capability of sending data over. If you have a bigger requirement, we have a Snowmobile, who here has seen or used a snowmobile in the past? A few people, yeah. So did you try to drive it when you got it? Because a lot of customers, when they get a snowmobile, they want to get up and drive it. So it has a 200 petabyte capability. You can bring in as much data as you want. It takes about 6 weeks to load and unload, and we drive it over to you with full security and all that comes around it. And then you can just send that over, and we'll unload your data in about 6 weeks. Now, security is paramount. Security is job number one at AWS and everything Amazon. So you can have the best model, you can have the best platform, the best data set, the best everything. If you don't have security, you have nothing. And so with that, we have a decent number of products in pretty much every angle and area of security with enough flexibility. You can bring in your own keys and you can use our keys. I mean, we can manage your keys for you or you can manage them yourself. And there are audits and logging mechanisms to make sure that you know who used the tool or who called the API at any time. So there's a decent array of tools and products and services that you can use to secure your data set, to secure your platform and infrastructure. Compliance is another thing, right? You know, you're building workloads and applications that probably require compliance in different regimes. And at AWS, we support a decent number of regimes. Again, there's an AWS compliance page with many of those, things from HIPAA to FIPS to FedRAMP to different number of ISO regimes. So again, use the security environment, the compliance environment, and everything else. So that's pretty much that about the talk. The other thing that I want to talk about is the Deep Learning Summit that is happening on Thursday. Make sure you show up there. There will be a number of hands-on sessions, and it's going to run all day, and we'll be happy to get to see you there and get some practical MXNet or TensorFlow or whatnot examples done. So it's on Thursday here. I'm happy to take a few questions if there's any.